Performance analysis of three-phase asynchronous motor with AC direct and VFD. Introduction. VFD is variable frequency drive. VFD used to control the speed of electric induction motor. Induction motors are fixed-speed motors which are used in most industries because of its reduced cost, reliability, and rugged nature. The speed of the induction motor can be changed by various methods such as poles changing, voltage changing, connecting the resistance in rotor circuit etc., but the most efficient method is changing the supply frequency and voltage to the motor. Speed is directly proportional to the frequency of supply. The variable frequency drive, VFD, varies the frequency and hence varies the speed or torque of the induction motor as per the requirements of the load. As VFD provides the power-efficient operation, smooth speed, and torque control but also leads the harmonics in the system. Harmonics are generated due to use of power electronic switching devices. These harmonics affect the performance of the induction motor. This paper describes the effect of harmonics on motor performance and also how to improve the performance of induction motor by using appropriate LC filter with the help of MATLAB/Simulink. This paper has detailed study of motor performance with different cases, those showing performance of induction motor. First, we study the parameters when three-phase induction motor is directly supplied by three-phase AC supply. Then these parameters are compared with the parameters those are getting when same three-phase induction motor is supplied by VFD without a filter. Then the performance is improved with the injection of LC passive filters in the system. 2. Procedure for frequency controlled induction motor drive. A variable frequency AC motor drive. The traditional variable frequency drive, known as a volts per hertz, V/Hertz, changes the motor's frequency and voltage using solid-state control units. B. Transistor-based variable frequency induction motor drives. The modern strategy for controlling the AC output of such a power electronic converters is the technique known as pulse width modulation, PWM, which varies the duty cycle of the converter switches at a high switching frequency to achieve a target average low frequency output voltage or current. In principle, all modulation schemes aim to create trains of switched pulses which have the same fundamental volt-second average as a target reference waveform at any instant. The major difficulty with these trains of switched pulses is that they also contain unwanted harmonic components which should be minimized. 3 main techniques for PWM exist. These alternatives are: 1. Switching at the intersection of a target reference waveform and a high-frequency triangular carrier, double-edged naturally sampled sine triangle PWM. 2. Switching at the intersection between a regularly sampled reference waveform and a high-frequency triangular carrier, double-edged regular sampled sine triangle PWM. C. Variable frequency control of induction motor. This method is used to control the speed of an induction motor. The synchronous speed and therefore, the speed of the motor can be controlled by varying the supply frequency. The synchronous speed of an induction motor is given by the relation shown below. Synchronous speed. 3. Three-phase induction motor. Three-phase induction motor is widely used in any kind of industry like automobile, cement, fertilizer, chemical, yarn production etc. because of its simple and rugged construction. A three-phase induction motor is singly excited machine. Induction motor works on Faraday law of electromagnetic induction. In this paper, behavior of an induction motor is studied when supplied with or without VFD by using MATLAB/Simulink. 4. AC/DC/AC converter. This converter is basically a combination of bridge rectifier, a LC filter and a DC/AC PWM IGBT inverter. A 60 Hz voltage source feeds a 50 Hz, 50 kW load through an AC/DC/AC converter. The 600V, 60 Hz voltage obtained at the secondary of the Y/delta transformer is first rectified by a 6-pulse diode bridge. The filtered DC voltage is applied to an IGBT 2-level inverter generating 50 Hz. The pulse width modulation, PWM, in the IGBT inverter at a 2 kHz carrier frequency. Sample time of 4 US is discretized in the circuit. Power inverters are the basic electronic circuits which is used to convert the DC to AC. The inverter input may be from rectified AC input or DC source. The categories with which we can giving switching to the inverter is square wave and pulse width modulated technique. Fig 2 AC/DC/AC converter. V 3-phase rectifier. Full wave bridge rectifiers are used, employing either silicon junction diodes or thyristors. Because of the arduous operating conditions in a power station and the need for maximum reliability in life. The main advantages of PWM converter is the value of the load. The PWM inverter corrects the output voltage by changing the width of the switching frequency of the oscillators. The main drawback of this inverter is the harmonic voltages of 5th, 7th, and other non-triplen odd multiple fundamental frequency distort the output voltage. Fig. 8 Discrete PWM Generator. The PWM generator block generates pulses for carrier-based pulse width modulation, PWM, converters using two-level topology. The block can be used to fire the forced commutated devices, FETs, GTOs, or IGBTs, of single-phase, two-phase, three-phase, two-level bridges, or a combination of two three-phase bridges. 7 LC Filter. A PWM sequence of pulses contains a useful base frequency and a set of high-frequency harmonics which are not required for common control purposes and altogether produce electrical noise. Electrical noise is always undesirable for the electromagnetic compatibility reasons. Moreover, some of the high-frequency harmonics of the PWM are harmful for the electrical machines, basically because of two phenomena: reflections in a long cable and the rather low high-frequency impedance of the electrical machine via its phases through the bearings to the ground. 8 Simulation and Results. In this simulation circuit model 3-phase induction motor fed by VFD system. Variable frequency drive system made up of PWM inverter. A 50 Hz voltage source feeds a 5 HP induction motor through an AC-DC-AC converter. The 600V 50 Hz voltage obtained at secondary of the Y/delta transformer is first rectified by a 6-pulse diode bridge. The filtered DC voltage is applied to an IGBT two-level inverter generating 50 Hz. The IGBT inverter uses pulse width modulation, PWM, at a 2 kHz carrier frequency. The circuit is discretized at a sample time of 2us. 9 Conclusion. Induction motor works very efficiently when we operate it with direct 3-phase AC voltage source. But the thing is, we need to control the speed of IM. In that case VFD is used to control the speed. But VFD made up of power electronics switching devices, so it injects peaky rotor current, oscillations in torque which results additional heating, power losses that affects power stability of IM. To improve the rotor current waveform, an appropriate LC filter is connected after the VFD converter. After LC filter rotor current of IM improves. Torque oscillations are damped and VFD converter output waveform becomes more sinusoidal.